today we are going to do basically the sums of heat transfer. So before I start the chapter, I request you all to open page 724 and 725 of your Nootan physics book. So before we start the sums, let us recap the formulas which we are going to use in this chapter. Basically, there are four formulas on which we are going to do the sum. One is the formula of amount of heat, which is delta Q is Ka, where K is the thermal conductivity, A is the area, delta T is, as you can see, is the change of temperature, delta small t is the change of time, and L is the length of the body. Delta T, as I told you, it is nothing but change of temperature, theta 1 minus theta 2. Now, Q ice, which you have done before also, that amount of heat needed by ice is nothing but M into L, where M is the mass and L is the latent heat. Q ice we have done. Now, dt by capital T by d small t. This is the Newton's law of cooling. dt by dt is equal to minus K, where K is the constant. T minus T0. What is T over here? Average temperature, which is T1 plus T2 by 2. And T0 is the surrounding temperature. Okay. After that, we have this Stephen's law, which is E is equal to sigma T to the power of 4, where T is the absolute temperature. And last but not the least, we come to Wien's law, which is delta M into T, where delta M is the maximum wavelength into the temperature is equal to a constant. Okay, so let's get started with the sums. So let us go through the first sum, number 1. So what is number 1 telling us? The cross-sectional area of a brick wall is 2 meters square. So as you can see, A is given as 2 meters square. Next, what is given? And its thickness is 12 centimeter. So L is given as 12 centimeter. So as it is given in centimeter, students will be converting it into meter. Okay, so it becomes 0.12 meter. Okay. After this, what is given to us? If the difference of the temperature between the two sides, that means delta T is already given to us. Okay. So if delta T is not given and suppose two temperatures are given, then you have to subtract the two temperatures to get delta T. But as they have already told here that the temperature difference is given, that means delta T is already given to you as 24 degrees Celsius. Okay. Next, calculate the amount of heat. Obviously, that means delta Q you have to calculate through the wall in watt hour. That means delta T is also given. It is equal to 1 hour, which is 3600 seconds. Okay, because hour is not the proper unit of time. Seconds is the proper unit of time. Okay. Now, what else is given? And the thermal conductivity of brick. That means K is given as 0.13 joules per second per meter degree Celsius. Okay, so we are given all the quantities. Now, delta Q, as you can see, as I have already told you, what is the formula? Ka delta T by into small t by L. So you see here, K is given, A is given, delta T is given, small delta T is given, and also L is given. Okay, so all the quantities are given to you. So you are going to solve it and get the answer in joules, because the unit of energy is nothing but joules. I hope you've understood the sum. It is a very easy sum. Okay, so we have done with number 1. So let's start with the number 2 sum, students. So what is number 2 sum telling us? Let us see. So number 2 tells that the area of cross section of an iron plate of thickness 2 centimeter. That means L is given as 2 centimeter. Now 2 centimeter is how much meter? 2 by 100. That means 0.02 meter. Done. Next, what else is given to us? It's given is 5000 centimeters square. That means area is given as 5000 centimeters square. Now 5000 centimeters square, obviously we have to convert into meter square. So that means 5000 by, now 1 centimeter is 1 by 100 meter. So 1 by centimeter square is 1 by 100 whole square. That means with 1 there will be 4 zeros. So we cut it and we get it as 0.5 meter square. We have got the area. Next, what else is given? The temperature of its surfaces are 150 and 140. So you see here two temperatures are given to you, 150 and 140. So what will be delta T? Delta T will be 150 minus 140, which is 10 degree centigrade. So we have got the difference of temperature also. What else is given? calculate the rate of heat transmitted through this plate. Now here students, they have asked you the rate of heat transmitted through this plate. That means they are asking you delta Q by delta T, because as I have already told you that anything by time is rate. Okay, rate means by time. That means from the formula delta T is coming below Q. So Q by delta T they are asking. What else is given? Coefficient of thermal conductivity. That means this you have to find out. K is given as how much? 0.015 kilocalories per second per meter per degree centigrade. So these are the things given to you. Okay, so 0.015 this. Okay. Now students, our formula, what was the formula? Delta Q is equal to Ka delta capital T into delta small t by L. Now delta small t has already come below Q. So delta Q by delta T, what will be the formula? It will be Ka delta T by L, because small delta T has gone down. Okay. So you know the value of K, you know the value of A, you know the value of delta T, you know the value of L. All the values are known to you. Put it, solve it and get the answer. Remember, since the unit is in kilocalorie, so your answer will also come in kilocalorie. Okay, this is also a very easy type of sum. So basically most of the sum students over in this chapter, we will be dealing with this, this formula. Okay, delta Q is equal to Ka delta T into small delta T by L. Okay, other sums also you will see that we will use this formula only. So students, we have done sum number 2 and sum number 1. So the sum number 3 is exactly same like sum number 1. So I expect you to do it by following the sum number 1 as you have done sum number 1. Now let's move to sum number 4 quickly. Okay, let's see what sum number 4 is telling us. So sum number 4 tells us if we use 12 millimeter thick special glass, the windows of a room, instead of 3 millimeter thick ordinary glass. That means delta L1, there are two thicknesses given, two lengths given. One is delta L1 and one is delta L2. So, so basically one is 12 into 12 millimeter, which is nothing but 12 into 10 power minus 3 meter. Okay, we are converting millimeter into meter. And another is 3 millimeter, which is nothing but 3 into 10 power minus 3 meter. Okay, so you have converted it. Now, what we have to do, what else is given? And the temperature inside the room is higher than the outside by 10 degrees centigrade. That means delta T is 10 degree centigrade. Then, how much heat per hour? How much heat per hour? That means delta Q by delta T they are asking. Okay. Delta Q by delta T per hour will be prevented from going out. The total area A, let me write it over here so that I can give you space. A is given as 5 meters square area. The total area of the glass is 5 meters square and thermal conductivity is K is given as how much? 2 into 10 power minus 4 kilocalories per second per meter degree centigrade. Okay, so these are the quantities given to you. Now they have asked you that how much quantity per this one, how much heat per hour will be prevented from going out. Now see here students, there are two thicknesses given. One is 12 and one is 3. That means two different glasses thicknesses there. So what you are going to do here? First you are going to find out delta Q by delta T1. Delta T said, but delta Q will be different because length is different. So what it will be? It will be equal to your Ka, because the thermal conductivity and area is the same in both the cases. Okay. So Ka delta T by delta L1. Okay, the first case, and delta Q2 by delta T will be Ka delta T by delta L2. Okay, so see here that all the values are given to you. Okay, K is given, A is given, delta T is given, delta L1 is given. So here everything is same except the L1 and L2, delta L1 and delta L2. Okay, so after you find out these two quantities, now what you are going to do to find out delta Q by delta T? Okay, to find out delta Q by delta T, just subtract delta Q2 by delta T minus delta Q1 by delta T. Just subtract the Q2 minus the delta Q1. Okay, so if you do it, you're going to get the answer. Okay, so this is how you're going to do the fourth sum. You're going to find out the delta Q1 separately by delta T and the second delta Q2 by delta T separately, and then subtract both of them to get delta Q by delta T. Okay, so this is sum number 14. Remember here, the thermal conductivity, the area delta T is same. What is the difference here? Only delta L1. Okay, students. So now let us move to sum number 5. Okay, so just do this sum, students. Now let us move to sum number 5. So let's see what sum number 5 is telling us. Sum number 5 tells us that one end of each of the two rods A and B of same metal. Again, same metal is given. So let us make two columns, A and B. These are the two rods. Okay, one end of each of the two rods A and B. Okay, so let's see what are the quantities of same metal and same area. So same area, that means A is same in both cases. A and B area is same. Okay, what else is same? And of cross section has been immersed in ice at 0 degrees centigrade. In which rod will the rate of heat conduction be more when their other ends are at 20 and 30? That means your delta T over here, suppose I write delta TA for you to differentiate between the temperature. One end is at ice, one end is in the ice 0 degrees centigrade immersed in ice, and the other, they have told, see, their other ends, that means A and B are at 20 and 30 degree. That means here it is 20 minus 0 and here it is 10. P is equal to 30 minus 0. That is the change of temperature. Okay. Next, there that is the first portion we have to solve, and the next portion also they have told that their ends are at 20 and 10 degrees respectively, and the length of A is twice the length. That we will do it afterwards. Let us do solve the first part. So first part they are telling the other two ends are at 20 and 30 and the length of A is half the length of B. Length of A is half the length of B. So if I take the length of B as L, they have told length of A is half of B. Okay, so if I take length as L, then length of B as L, then length of A will be half L, because half the length. Obviously, that means the metals are same over here. So obviously K will be same in both the cases. Okay, what they have asked, what will be the rate of heat conduction? Rate means delta Q by delta T. Okay, so let us compare. So delta QA by delta T by delta QB by delta T. We have to find this. Okay, which is equal to KA, both are same, delta TA by LA by KA delta TB by LB. You can cancel out K, becomes easier. So what is TA? It is 20. And what is LA? It is half L. And what is TB? It is 30. This is nothing but 30 and this is nothing but 20. So 30 by LB is nothing but L. So just solve it and you will get the ratio between the heat conduction of A and heat conduction of B. Means not heat conduction, basically the amount of heat conduction, the rate of amount of heat conduction of rod A and rod B. Okay, this is the first part we have done. Now in the second part also they have told it. The ends are at 20 and 10 degree respectively. Now, so what will be in this case? This is the first case we have done. So in the second case, what will be delta A? The temperature they have told 20 and 10 degree. That means 20 minus 0. Okay, which is 20 degree. And here number 2, delta TB will be 10 minus 0, which is 10 degree centigrade. Okay. What else is given? And the length of A is twice the length of B. That means if we take LB, okay, this is the second case, is equal to L, then in this case LA will be twice the length of B, that means 2L. Okay, so same way, just put it the formula QA by delta T by delta QB by delta T. Now in the previous case only you have seen that KA is same. So and here also I am not writing down KA anymore because it will ultimately get reduced. So I am writing TA by LA by delta TB by LB. So what is TA over here? 20. What is the length? 12. What is TB? 10. What is the length? L. Just solve it and get the answer. You will get the ratio between the rod of between these two rods. Okay. Hope this sum is clear to you. So this type of sum, students, it is nothing just solving of the sum. If you can read the sum properly, if you are reading the sum properly and writing down each and every quantity which is given to you, this is the basic formula which you are applying over here. Just remember, if they have asked you amount of heat conduction, okay, it is delta Q. And if they are asking you the rate of amount of heat conduction, be very clear, students, it is delta Q by delta T, because rate means by time. Okay, just be clear about it, what the question is asking. And as you go through the question, student, please keep on writing the quantities. It will be easy for you to solve the sum. Okay, now let's move to sum number 6 quickly. So just put the values, read the sums, just put the values. The sums are really easy sums. Most of the sum in this portion, you will see that it is from this formula only, delta Q. Okay, sum number 6, let us do the sum. The thickness of a sheet of nickel is 0.4 centimeter. That means L is 0.4 centimeter. As we always do, we convert it into meter. 0.4 by 100, which is, I can write it as 10 to the power of -2 meter. Okay, you have done it. Next, the temperature difference between its two faces is 32 degree. Very good. Delta T is given as 32 degrees centigrade. We don't have to solve because delta T is given to us. It transmits heat through an area of 5 centimeter square. A is given as 5 centimeter square, which is 5 by 1 with 4 zeros, because 1 centimeter is 1 by 100 meter. Centimeter square is equal to 1 by 100 whole square, which is 10 to the power of 4. So I can write it as 10 to the power of -4 meter square. Okay. Next, what is it is given? At a rate of 200 kilocalorie per hour. That means delta Q by delta T is given as how much? It's given as 200 kilocalorie per hour. Now students, it's given kilocalorie per hour. Kilocalorie is okay, but hour is not okay. So we are going to convert it into seconds. Okay, that means 200 by 3600 seconds, because 1 hour is 3600 seconds and it's given per hour, that means by hour. So instead of hour, I have written 3600 seconds. Okay, so if I reduce it, I am getting 1 by 18 second. Okay, next, what they have asked, calculate the coefficient of thermal conductivity. Very easy. So what is our formula? Delta Q by delta T is equal to Ka delta T by L. Okay, everything is given. So what will K be equal to? Kp will be equal to, this gets multiplied over here. So delta Q by delta T into L, and this is along with A, so it will come down. So A into delta T. Okay, so just you know the value of delta Q by delta T, put the value of L as it is given, put the value of A as it is given, put the value of delta T as it is given, solve and get the answer. Okay, so very easy sum. You can just put the values, solve and get the sum. Okay, very easy. Same. All basically most of the sums are from thermal conductivity only. Okay. Now let us move to the 7th sum quickly. 7th sum also basically it is heat thermal conductivity portion only. Only the questions are different, but sums are same. Okay. Okay. Now let's do the 7th sum. The opposite faces of an iron cube are in steam 100 degree and in ice 0 degree centigrade. So obviously what will delta T be equal to? 100 minus 0, that is 100 degrees centigrade, because one higher temperature is at 100, lower temperature is 0. So 100 minus 0, which is 100 degree. Delta T is 100 degrees centigrade. Next, each side of the cube is 2 centimeter. So each side of the cube is 2 centimeter. That means L is given as 2 centimeter. Okay. So we can convert it into meter. 2 by 100 meter. Okay. Now, we are not going to convert it into meter because the rest of the quantities are given in CGS unit. Okay, so let us keep 2 as it is. Now it's given, and thermal conductivity of iron is 0.2 calorie per second. So thermal conductivity K is 0.2 calories per second per centimeter per degree centigrade. So you see here it's given in CGS unit. So no need of converting. If units are same, no need of converting, because if units are, if you don't convert all the terms into same unit, if you do the sum, your sum will be wrong. So always try to convert either all in SI or all in CGS, whichever is preferable to you. Okay. So a K is given as 0.2. How much ice? So we have to find out how much ice. That means mass of ice we have to find out. Will melt in 5 minutes. Time is given as 5 minutes. Okay, that means delta T is given as 5 minutes. So 5 minutes will convert into second because there is no CGS unit of minute. So it is 300 seconds. Okay. Now what else is given? Latent heat L is given as 80 calorie per gram. Okay. So in class 10, when you have done the calorimetry chapter, you have obviously done that the amount of heat of ice is nothing but mass into latent heat. Okay. So all quantities are given. Let us put it in the formula delta Q. I am writing down ice so that I can put the next formula over here. Delta T is equal to K A delta T by L. Okay, so let us put the formulas now. Instead of delta Q ice, you are going to put M into L by delta T is equal to K A delta T by L. Now see here, M we have to find out. Okay, L is given to you. Delta T is, we have got it. K is given to us. Area is not given. Okay, area we will be calculating. So obviously it's given that it is a, what it is given? It is a cube. Okay, so if it is a cube, what is the area of a cube? Area of a cube is nothing but 2 into 2. Okay, which is 4 centimeters square. So area is 4 centimeters square. We will put it over here. Now what is delta T? Delta T is given as 100 and L is given as 2. Okay, so to find, so all things is given to us. Okay, just put the value, solve and get the answer. Okay, just remember here, whenever we will be using ice, in ice case, we are going to use the formula M into L. Okay, mass into latent heat. Okay, now let's go to the next sum quickly. Sum number 8. Okay, sum number 8, it says, two vessels of different materials, obviously different materials means there will be different conductivity, thermal conductivity, are identical in size and wall thickness. Identical in size and wall thickness. Okay. They are filled with equal quantities of ice. That means mass of ice is equal at 0 degrees centigrade. If the ice melts in 10 and 25 minutes respectively, then compare the coefficient of thermal conductivity of the material of the vessel. So what is T1 given? 10 minutes. T2 is given as 25 minutes. Since both are in minutes, are not converting into second, let it be in minutes only. Okay. So what else is given? Nothing is given. Now, if you read the sum properly, students, two vessels of different materials are identical in size. That means a different materials means your thermal conductivity will be different. So let me take it conductivity as K1 and here as K2, which we have to find out. Okay. Rest, see, wall thickness is same. That means this and this, both the L's, this though you have to find out, L are same. Okay, that means the length of the first metal and the second metal is the same because thickness is same. Okay. are filled with equal quantities of ice. Okay, at 0 degree centigrade, temperature also is same. Okay, so means everything is same except the time. Okay, so let's put the formula. So delta Q1 is equal to K1 A delta T into small t by L, because length is same, and delta Q2 is nothing but K2 A delta T let me write here T1 and T2 by L. Okay, so if I compare this to Q1 by Q2, okay, so this Q is also same over here, because both of them here they are releasing equal amount of heat. So delta Q1 is equal to delta Q2. So if I equate this to expression K1A delta T1 by L is equal to K2A delta T into delta T2 by L. So you say LL gets cancelled, AA gets cancelled, delta T gets cancelled. What we are left with finally? Finally we are left with K1 by K1 delta T1 is equal to K2 delta T2. Okay, what we have to find out? K1 by K2, right? We have to find K1 by K2. So what will be K1 by K2 equal to? It will be equal to delta T2 by delta T1. Okay, delta T2 by delta T1. You know the value of delta T2, you know the value of delta T1. Put it, solve it and get the ratio. Okay, so that's why I'm telling you again and again, student, read the sum properly. In the sum, everything is given to you. The thing is that you have to read it properly and identify which quantities are given to you. If you can identify the quantities, sum is very easy. Okay, now let's quickly do the sum number 9. Okay, sum number 9, let's do it and see what they are telling. Sum number 9. Okay, sum number 9, it tells one end of a 25 centimeter long metal bar. That means L is given as 25 centimeter, which is nothing but 0.25 meter. Okay, is in steam and the other is in contact with ice. That means what is the temperature for steam? 100 degree centigrade. What is the temperature for ice? 0 degree centigrade. So what is the change of temperature delta? It is 100 minus 0, which is 100 degree centigrade. Next, let us proceed. If 12 gram of ice, that means mass of ice is given as 12 gram. Okay, you convert it into means kg, 12 by 1000 kg. Okay. If 12 gram of ice melts per minute, that means time is given as, delta T is given as 1 minute, which is nothing but 60 seconds. Okay. What is the thermal conductivity of the metal? K they have asked. Okay. Cross section of the bar, A is given as 5 centimeter square, which is 5 into 10 to the power minus 4 meters square. Okay, so we have done it, and the latent heat L is given as 3.4 into 10 to the power 5 joules per kg. Okay, so these are the quantities given to you. What you are asked to find out? You are asked to find out K, same type of sum. So Q is equal to Ka delta T into small delta T by L. So what will be K equal to? K will be equal to Q. Now, what is Q over here? Since we have taken the case of ice, Q of ice. Okay, so we will further break ice into M into L. Okay, so whenever ice is given, students take Q as M into L. So ml is equal to Ka delta T into delta T by L. So ultimately, what is the how will you find K? K is nothing but M capital L is latent heat and this small l is the length, by A into delta T into small delta T. Okay, just put the values, solve and you'll get the answer. Okay, now let's go to the next sum quickly. These sums are all same formula only things are different. Okay, so let's go to sum number 10 quickly. Okay, so please solve those sums which means I'm leaving it for you to solve and see that you get the answers. Okay, sum number 10, let's do it quickly. It's given two rods of same metal. Mind it, same metal. That means K is same over here. Okay. And of same cross section. Means area is also same. And let me make a column. Okay. So here area we have got same. And conductivity also same. Thermal conductivity also same. Okay. Now what else is given? Have length 0.5 millimeter and 0.8 millimeter. That means L1 is 0.5 millimeter, right? Sorry, meter. Meter it's given. And L2 is 0.8 meter. Okay. What else is given? The temperature difference between the ends of first rod is 40 degrees centigrade. Find the temperature difference across the second rod. That means delta T is given as how much? 40 degrees centigrade. T1. You have to find out delta T2. Oh, I'm sorry. It should be T, capital T. Otherwise, you all will get confused. Okay. Now, find the temperature difference across the second rod if the rate of heat conduction is equal in both cases. That means delta Q1 by delta T and delta Q1 by Q2 by delta T. Both are same. Okay. It is equal. Okay. So, let us put it in the formula. So, if we put it in the formula, delta Q1 by delta T is equal to Ka delta T T1 by L1. Okay. And delta Q2 by delta T is equal to Ka delta T2 by L2. Okay. Now, these two are equal. Okay. So, instead of this two, let us equate it. So, Ka delta T1 by L1 is equal to Ka delta T2 by L2. K gets cancelled, A gets cancelled. What we are left with? Delta T1 by L1 is equal to delta T2 by L2. What we have to find out? We have to find out delta T2. So, delta T2 is nothing but delta T1 into L1 into L2. Just delta T1 you know is 40, L1 is you know 0.5, L2 you know is 0.8. Put the value, solve, and you get delta T2. Solve it and you'll get the answer. Okay. So, you see, just means putting the formula, you get the sum. Okay. Now, next sum, students, sum number 11 is exactly same like sum number 10. So, I'm not going to solve that sum. That sum I'm leaving up to you to solve it, because sum number 11 is exactly like sum number 10. So, if you have understood sum number 10, you will be quick, means you will easily do sum number 11 also. Okay. Let's go to sum number 12. Now, sum number 12, they have given what? 3 thermometers A, B and C read respectively 36, 32 and 27. So, there are 3 thermometers A, B, C reading 32. What are the temperatures? T1 is 36, T2 is 32 and T3 is 27. Okay. A lies between body and vest. So, a man is wearing a vest and the temperature between the vest and the body is your A. A is lying between your body and vest. Okay. B lies between vest and shirt. That means after the vest, the man is wearing a shirt. So, the thermal conductivity K between the vest and the shirt is your B, and C between the shirt and the coat. After shirt, he is wearing a coat. So, between shirt and coat is C. If the vest and shirt are equally thick, calculate the ratio of the thermal conductivities. Vest and shirt means this two. Okay. Vest and shirt means this two. Okay. Because this is the coat one. Okay. So, what you are going to do? So, you see here that means find if the vest and the shirt are equally thick, calculate the ratio of thermal conductivity. Now, you see there all the rest of the quantities are same. Okay, obviously everything is same because the man is the same. So, we are left with the only choice that K1 delta T is equal to delta T1 is equal to K2 delta T2. They have not asked T3. Okay, so what is this delta T1? It is the temperature between the man. Okay, they have asked what? The thermal conductivities, the ratio of the thermal conductivities. So, A is between the body and the vest. That means this is the 36 and 32. So, what is delta T1 equal to? 36 minus 32, which is 4 degrees centigrade. And what is delta T2? It is between 32 and 27. Okay, temperature difference between the vest and the coat, shirt and the coat. So which is 5 degrees centigrade. Okay, so you got the temperature difference, just put it. So what will be K1 by K2 equal to? It will be equal to your delta T2 by delta T1. Just put it, solve it, and you get the answer. So you see, sums are really simple. If you can understand the terms, it's very easy. Okay, because rest of the quantities are same. Now let's quickly move to sum number 13. Let's do sum number 13. Okay, let's see what sum number 13 tells us. Sum number 13 tells us that the ratio of the area of cross section of two conductors of different metals is 1:2. That means A1 by A2 is 1:2. That means 1 by 2. Okay. So what is A1 equal to? What will be A1 equal to? I am doing it here only. Half A2. Okay. So A1 will be half A2. Let's see. And the ratio of the thermal conductivities of the material is 4:3. That means K1 by K2 is equal to 4 by 3. So what will K1 be equal to? 4 by 3 K2. Okay. Next, keeping equal temperature difference. That means delta T1 is equal to delta T2 between the two ends. And the rate of conduction heat are also equal. That means delta Q1 by delta T1 is equal to delta Q2 by delta T2. Equal. Everything is equal. Determine the ratio of the length of the rod. You have to find out the ratio between the length of the rod. So since these two are equal, so let me equate it. So K1, area is different, A1, delta T is same. Okay, so I am writing as delta T. Let me write it as delta T only. Both are equal. Delta T. And since I have taken delta T1 below, so no need of writing delta T over here. L1 is equal to K2 A2 delta T by L2. Delta T gets cancelled. Okay. So you have to find the, what you have to find? The ratio between L1 and L2. So what will be L1 by L2 equal to? L1 by L2 will be equal to your K1 A1 by K2 A2. Okay. So L1 by L2 will be equal to K1 A1 by K2 A2. Now bring K2. See, we have converted K1 and A1 in terms of K2. So let me put K1 as what? 4 by 3 K2 and A1 as half A2 by K2 A2. Now after this, you can solve it and get the answer. Okay. It's an easy sum after this. Okay, so see students, if you can read the sum, analyze the sum and go through the quantities, sums are really easy. Okay, now let us do sum number 14. Let's see what sum number 14 tells us. Okay, sum number 14, let's see. Two vessels of different materials are identical in shape and size. Different materials means thermal conductivity is different over here. So let it be K1 and K2. Okay, two metals. Identical in shape and size means obviously area and length is same. So L1 is equal to L2 is equal to L and A1 is equal to A2 is equal to A. Area is same. Okay. Both are filled with equal masses of boiled water and are placed on the same heater. That means temperature also is same. That means delta T1 is equal to delta T2 is equal to delta T. Let us take the temperature as delta T. Okay. If thermal conductivity of the metal of the vessel, so K1 is given as how much? K1 is given as 5 into 10 to the power minus 2 and K2 is given as 3 into 10 to the power minus 2. Okay. So it is given kilocalorie per second per meter degree centigrade and this also kilocalorie per second per meter degree centigrade. Okay. So they have asked calculate the ratio of the timings delta T. They have asked taken by the water in the vessel to convert into steam. That means they have asked T1 and T2, delta T1 and delta T2. So what is so obviously it's it's given that calculate the ratio, okay, of the timings taken by the water in the vessel to convert it to steam. So we can see that delta Q is same in both the cases. So we can write K1 A1 delta T delta T1 into delta T1 by L1 is equal to K2 A2 delta T2 into delta T2 by L2. Now you can see that K1 is different. Let me keep it as K1. A1 is same as A. Delta T is same as delta T. Delta T1 is different and L is same. And here also K2 A area is same. Delta temperature change is also same. Delta T2 is different and length is same. So length gets cancelled. Delta T A gets cancelled. What we are left with? K1 delta T1 is equal to K2 into delta T2. So delta T1 by delta T2 will be equal to nothing but K2 by K1. Just solve it. Put the value. You know the value of K2. You know the value of K1. Put it and you get the answer of delta T1 by delta T2. Okay. So it's a very easy sum. Let's do sum number 15 quickly. Number 15. Let's see what it is telling. The plane surfaces of two sheets of different metals are kept in contact with each other. The thickness of the sheet, that means L1 is given as 2.5 centimeter, L2 is given as how much? 3 centimeter. Okay, since both are in centimeter, I am not converting it to meter. If required, afterwards I will convert it. Okay. And the ratio of the thermal conductivities, that means K1 is K1 by K2 is given as 5 by 6. Right, 5 by 6, yes. So we can easily write K1 is nothing but 5 by 6 K2. Okay, so always convert the two one thermal conductivity in terms of the next thermal conductivity. Okay. So if the outer surface of the sheet be at constant temperature 100 and 10 degree respectively, calculate the temperature of interface. So let the common temperature be T. Okay, let temperature of interface be T. Okay, let the temperature of interface be T. Okay. So what is delta T in this case? It is 100 minus T. And what is the delta T in the other case? Delta T2, it is T minus 10, because T is the equilibrium temperature over here. Okay. So what they have asked, calculate the temperature of the interface. So let's solve the sum. So we know delta, obviously heat will be same in both the cases. So we can write K, K1, A1. So obviously here it's given that the plane surface of two sheets of different metals are kept in contact with each other. Okay. So here you have to take the area as the same, because the two metals are having the same area. Okay. So Ka delta T1. Okay. We can take it as A only because area is same. Into delta T1. Okay, time also is the same. So delta T, let me take it by L1. Okay, that's equal to K2 A delta T2 into delta T by L2. Okay, so delta T gets cancels, A gets cancelled. So we are left with K1 delta T1 by L1 is equal to K2 delta T2 by L2. Okay, so now we will be putting the values. So instead of K1, I can put 5 by 6 K2 into what is delta T1? 100 minus T, okay, by 2.5 is equal to the next temperature. Let me write it over here. It is equivalent to your K2 into delta T is nothing but T minus 10, okay, by 3. Okay, just you need to solve it, prove it. Okay, obviously you can see that K2 gets cancelled. After this, just solve the linear equation and find out the value of T. Okay, you will easily get the value of T over here. Now sum number 16 and 17, basically students, it is based on Newton's law of cooling. Okay, the two sums 16 and 17, Newton's law of cooling, it is based on. So till now we are doing sums of thermal conductivity. Now two sums 16 and 17 will be basically dealing with Newton's law of cooling, which is dt, capital DT by small dt is equal to minus K T minus 0, where T is the average temperature and T0 is the temperature of the surrounding. Now let's go through the sum. It's given a liquid initially at 70 degrees centigrade cools to 55 degrees centigrade. So obviously sum number 16. So dt, that means what is the change of temperature over here? 70 minus 55, which is your 15 degrees centigrade. Okay, fine. Next, in 5 minutes. That means in 5 minutes means your dt, small dt is 5 minutes. Okay. Let me keep it in minutes. Afterwards, I'll convert into seconds. Okay. Now, and 45 degrees centigrade in 10 minutes. Okay. So, the second part I'm coming to it afterwards. So, we have got dt, we have got t. We have to find, what you have to find? What is the temperature surround? T0 we have to find out. So, let us do it afterwards. So, let us find T. T is nothing but the average of the two temperature. That means 70 plus 55 by 2, which is 125 by 2. Okay. So, let us put it in the equation. So, what we are getting? 15 by 5 is equal to minus K, 125 by 2 minus T0. Okay. This is equation 1. Next part which is given, and means initially it is a 70. Okay. Then it is cooling to 45 degrees centigrade in 10 minutes. Okay. Similarly, for 10 minutes and for students, we have found out the T1. Now we are going to find out the T2 similarly. So you see here that initially the temperature of the body was at 70. Now it has come down to 55, and from 55 it has come down to 45. So what is the change of temperature over here? 55 minus 45, which is 10 degrees centigrade. And what was the change of timing over here? 10 minutes minus 5 minutes, which is 5 minutes. Okay, and what is the T2 or the average temperature in the second case? It is 55 plus 45 by 2, which is 50 degrees centigrade. Okay, so again let us form an equation like we have done for 1. So it is 10 by 5 is equal to minus K 50 minus T0. Basically we have to find out T0 or the surrounding temperature. This is equation 2. Okay, now we have got the two equations. Okay, now let us solve the two equations. So we can obviously divide it and get it. So if you divide 1 by 2, okay, if you are dividing, you have to divide equation 1 by dividing equation 1 by 2. So what will you get? 3 is equal to minus K. Now 25 by is 62.5, I hope. Yes, 62.5 minus T0 by 2 is equal to minus K 50 minus T0. This is the equation you get. Minus K cancel. So you ultimately left with 3 by 2 is equal to 62.5 minus T0 by 50 minus T0. Now just solve it in the linear equation and you will get the answer for T0. T0 is nothing but the temperature of the surrounding. Okay, so we'll get the answer for the temperature of the surrounding. Okay, now let's go to the 17th sum. 17th sum is also same like the 16th sum. It's also based on Newton's law of cooling. Okay, so let's see what it is telling us. Okay, a pan filled with water, hot water, or hot food cools from 94 to 86 degrees centigrade in 2 minutes. Similarly, just same time, okay. So dt1, let us take dt1. So it is cooling from 94 to 86. Okay, so what is dt1 here? 94 minus, this is 8 degrees centigrade. Okay, now what is the temperature in 2 minutes? So time dt1 is given as 2 minutes. Okay, next they have asked when the room temperature is 20 degrees centigrade. Okay, how long will it take to cool the food from 71 to 69 degree centigrade? Okay, so here the surrounding temperature Ts or TO, we have taken it to TO, is given as 20 degrees centigrade. Fine. So let us form an equation over here. So what is the T over here? T is nothing but 94 plus 86 by 2, which is 180 by 2. Yes, which is 90 degrees centigrade. Okay, so T is given as 90 degree centigrade. So dt1 by dt1 is equal to minus K 90 minus 20. Okay, so we get the value. Let us put the value 8 by 2 is equal to minus K 90 means 70. We are getting here 70. Okay, so we get the value of K over here. So minus K is nothing but 70 by 4. right? No, it's 4 by 70, sorry, 4 by 70. Okay, we have got the value of minus K. Now, what they have asked, how long will it take to cool from 71 to 69 degrees centigrade? So, what will be delta dt in this case? Dt is nothing but 71 minus 69. Okay, which is 2 degrees centigrade. What will be the T in this case? 71 plus 69 by 2, which is 70 degrees centigrade, right? If I add them, average. So let me put what we have to find out. We have to find out dt by dt. We have to find out dt over here is equal to minus K T minus T0. Okay, so here we got T as 70. So what is dt? Given what we have got dt, 2 dt we have to find out. K value we have just now got minus K as 4 by 70, and T minus T0 is nothing but 70 minus 20. That is, we get 2 by dt is equal to 4 by 70 into 50. Okay, just solve it and you get the value of dt. Mainly you are asked to find out the value of dt. If you solve it, and you will get the answer for dt. Okay, I hope this is clear to all of you. So just students, if you put it and solve it, and you get the answers very easily. Okay, so if you solve it, you will see, students, this answer is coming in minutes because we have already done it minutes. Okay, so don't get puzzled because in your book I've seen it's given in second. Minutes you convert into second and you'll get the answer. Okay, so don't worry about it. Okay, now let us go to the next sum, which is sum number 18. Now students, now we are going to use the Stiffel's law as well as the Wien's displacement law from the next sum. Okay, so let's do sum number 18. Okay, sum number 18, it's given the rate of radiation from a black body at 0 degrees centigrade. That means T1 is given as 0 degrees centigrade. Convert it into Kelvin. That means 0 plus 273, which is 273 Kelvin. Okay, and the heat E1 is given as Q, joules per second. Find the rate of radiation by the same black body at 270. That means T2 is given as 273 degrees centigrade. Obviously convert it into Kelvin. That means 273 plus 273. Okay, which is equal to 546 Kelvin. Okay, so two temperatures are given. We are asked to find out E2. Very easy sum. Okay, so what is the formula? E1 is sigma T1 whole 4 and E2 is nothing but sigma T2 whole 4. Okay, so sigma gets cancelled. So E1 by E2 is equal to T1 whole 4 by T2. Okay, so all the quantities are known to you. So what will be E2 equal to? E2 will be equal to T1 by T2. Now this both are whole, to keep it as whole 4. Okay, so to find out E2, it will be into I think I've done the reciprocal over here. So to find out E2, it will be equal to E1 into, this will get reversed over here because E2 will get multiplied over here. When this one comes this side, it will become T2 whole 4 by T1 whole 4, which you can also write it as T2 by T1 whole 4. Okay, so put these values, solve it, bring it in the power of 4. E1 is given as Q, so you will get your answer in Q. Okay, this much Q. Okay, that I leave it to you to solve. Okay, please put the values, solve, and get the answer for E2. Okay, now let's move to next sum. Now next sum, in 19th sum is exactly same like 18. Only the difference is that instead of Q, they have given a particular value, which is more easier to solve. Okay, but the formula is same. E1 by E2 is T1 4 by T2 4. Okay, there is no other formula. So sum number 19, please do it yourself. Okay, let's move to sum number 20 now. Let's do quickly sum number 20. This chapter sums are really easy. Only have to go through the sums. Okay, sum number 20. A black body at 127 degree temperature. That means T1 is given as 127 degree centigrade, which is 127 plus 273, which is 400 Kelvin. Okay, is radiating energy from its surface at a rate of 1 into 10 to the power 6 joules per second. That means delta Q by delta T. Okay, they have given here delta Q by delta T. It is nothing but E, radiant energy. Okay, radiant energy is given as 1 into 10 to the power 6 joules per second. Okay, remember delta Q by delta T is nothing but radiant energy. Okay, find the temperature of the black body, that means T2 you have to find out, at which the rate of energy radiation be 16 into 10. That means E, this is E1, E2 will be 16 into 10 to the power 6 joules per second per meter square. Okay, so there's only one basic formula, E1 by E2 is equal to T1 by T2 whole 4. Okay, obviously T2 is not known to you. Okay, so let's not write whole 4. You can write it also, not it doesn't matter, by T2. Okay, so what will be T2 equal to? T2 will be equal to T1 whole 4 into, when this comes this side, it will become E2 by E1. Okay, yes, E2 by E1. You know the value of T1, you know the value of E1, you know the value of E2. Solve it, and T2 will be nothing but, as it is whole 4. Okay, so when it comes this side, it will become T1 whole 4 into E2 by E1 root over of 1 by 4th. Okay, just put the values, solve and get the answer. Okay, so just put it and solve, and I hope you can put the values, solve and get the answer. Okay, sum number 20. Now, sum number 21 is exactly same like 20. So, please do it yourself. Okay, more you do, more you learn the sum and try to do it, you learn the sum yourself. Okay, I'm doing it, you're observing. That is not the main thing. Thing is that you're able to do the sum yourself. That is the most important thing. So, in between the sums, which is same type, I have left it up to you for you to practice. Now, let's go to sum number 22. Sum number 22, it's given that the luminosity of regal star in Orion constellation is 17,000 times that of the sun. Okay, so let us take the radiant energy of sun as ES. Okay, so the luminous intensity, luminosity is nothing but the radiant energy. So the regal star is 17,000 times that of the sun. Okay, the surface temperature of the sun is 6,000 Kelvin. That means TS is given as 6,000 Kelvin. It's already given in Kelvin. You are asked to find the temperature of the star, TR. Same, it's the same, exactly same of the Stephen's law. So, ER by ES is equal to TR by TS whole 4. Okay, so ER, it's given in the ES form. ES by ES is equal to TR is given as, TR you have to find out, okay, whole 4 by 6,000 to the power of 4. Okay, so ES gets cancelled, just solve it. So TR will be equal to 6,000 whole 4 into 17,000 to the power of 1 by 4th. Okay, just solve it and you will get the answer. Okay, students, now this now few sums are there that you will get, you will be easily find out the 4th factor, 1/4 factor, but there are some sums where you are going to get it in the decimal value. So to do your sums first, please use your scientific calculator, because you are now allowed to use calculator and you have to means utilize your time. So I suggest you that use a scientific calculator to do the calculations quickly. Okay, don't waste your time. Now next sum, 23rd, I am not going to do. Instead, I am going to do sum number 24. Why? Because 24 is little bit different, but 23rd is easier. So 23rd sum, I am not going to do that. You will do. I will do the 24th sum. Okay? Let's do 24th sum. What is 24th sum telling? The sun and the moon emit maximum radiation at 5,000 angstrom and 15 angstrom respectively. That means the lambda of the sun is how much? 5,000 angstrom. Now remember student, 1 angstrom is 10 to the power of minus 10 meter. Okay, 10 to the power of minus 10 meter. Okay, and another is radiating how much? It is radiating, the moon is radiating 15 micro angstrom, I think. It's given micro angstrom, right? Yes, micro angstrom. Now, what is micro? Micro is 10 to the power of minus 6. Okay, so ultimately we will get it as 15 into 10 to the power of minus 6 into 10 to the power of 10. That means 15 into 10 to the power of 4. Okay, you can convert it into angstrom. Okay, now so we have converted into same unit. Okay, so it's given that if the temperature of the sun, that means TS, is given as how much? 6000 Kelvin. Okay, calculate the temperature of the moon, T of the moon. Same Stephen's law. Okay, so sorry, this is not Stephen's law. I'm very sorry, because here wavelength is given. So basically here we are going to apply Wien's displacement law. Okay, so it is nothing but lambda s into Ts is equal to lambda m into Tm. Okay, so Tm you have to find out. So what will Tm be equal to? Lambda s into Ts by lambda m. So lambda s you know, Ts you know, lambda m you know. Put the value, solve and get the answer. Okay, so it's very easy. Okay, next let us do the last sum, 25th sum. Okay, 25th sum, let's see what's the 25th sum is telling us. Okay, 25th sum, in solar radiation the value of lambda m. Now this last sum, okay, again we are using Wien's law over here. Okay, so lambda m is equal to 4753 angstrom. Okay, and the temperature of the sun T is 6080.3 Kelvin. Calculate the Wien's constant B. Very easy sum. So what is the formula? Lambda m into T is equal to B. You know the value of lambda m, you know the value of T, just find out B. Okay, and you will get a value which I had told you in the class, and it's a constant value. Okay, which is the value of this constant, Wien's constant over here. Okay, you solve it. This sum is basically, it is a proof of how to get the Wien's constant. Okay, so if you solve this sum, you're going to get a value which is equal, which I have told you in the class, which is the value of B. Okay, so just solve it and get the answer. You'll get the Wien's constant, and its unit is meter Kelvin. Okay, we'll get the answer in meter Kelvin. Okay, so with this we finish off with the heat transfer sums. Okay, so you see here basically there are only 4 formulas we are doing sum. One is thermal conductivity formula, one is Newton's law of cooling, one is Stephen's law, and one is Wien's displacement law. Nothing else is there. Okay, so it's a very easy chapter. Okay, so I hope you all do the sums and send me as soon as possible. Okay, so this is your 4th assignment. So you are going to complete it and send me in the Google Class too. Okay, bye students. 45 degrees.